Recently, two separate NASA studies illustrated the complex relationship between human activity and our atmosphere. First up, a team led by scientists at NASA's Jet Propulsion Laboratory focused on drops in nitrogen oxide emissions during the COVID-19 lockdowns. Nitrogen oxide comes from sources like power plants and car exhaust, and reacts to form surface-level ozone, which is harmful to human health. Using NASA satellites, the team saw that the lockdowns left a distinct fingerprint on ozone levels in the lower atmosphere, which dropped about 2% globally. And while this may seem small, such a drop in harmful ozone would take about 15 years to achieve under even the most aggressive emission control scenarios. Interestingly enough, the team found that these drops were not uniform across the globe, that where and when the lockdowns occurred was very important in determining the impact on the atmosphere. Taking a look at these regions, with blue representing below normal levels of ozone in the lower atmosphere, we can see that both Asia and the United States have a substantial impact on harmful global ozone levels. Factors like prevailing winds, air temperature, and moisture content all impact how efficiently ozone is produced and moves throughout the globe. Like ozone, CO2 is a long-lived gas that is easily transported through the atmosphere, which means that any changes in emissions is mixed with many different influences from both near and far. This makes it challenging to track and measure how local changes in human activity actually impact the levels of this greenhouse gas. Using NASA's OCO2 instrument and the GEOS model, NASA researchers were able to spot short-term regional fluctuations in the atmosphere due to drops in human activity related to the lockdowns. This is the first time changes in CO2 measurements have been tracked at such a scale all over the globe. The team's results showed that the CO2 emissions dropped significantly in the Northern Hemisphere from February through May and rebounded during the summer when some restrictions eased. The team was also able to better distinguish which monthly CO2 fluctuations were due to human activities and which were due to natural causes, like the Australian wildfires and ocean circulation patterns. This is important because distinguishing between human and natural causes is a critical step towards measuring human activity's collective effects on CO2 emissions in near real time. The lockdowns surrounding COVID-19 were an unprecedented global event that highlighted the complex relationships between emissions and the atmosphere. By studying these relationships, we can gain insights that could help us better design sustainable measures that can improve both human health and the climate.